Okay, hi everyone. Around the time when you watch my lecture, I am going to be in Boston for NSA CAE directors meeting. Therefore, I'm going to give you my video lecture. Today, I'm going to make it a little short, but short recording, but at your side, if you do not have sufficient background skills, I want you to take time to catch up. Okay. Last time we stopped at the K nearest neighbor algorithm. That algorithm is very efficiently used for classification, and classification is one of the very important techniques in data mining and also artificial intelligence, more specifically machine learning. In cybersecurity, machine learning and classifications are also very important in these days. Cyber attack and cyber threats are rapidly evolving and fully utilize the current and future technologies. So cybersecurity also uses the machine learning technique. Therefore, previously unknown patterns may be used so that our cyber threat detection or prevention program needs to be also correspondingly adaptive to their advancement. Classification in K and N, as you may be already understanding, say we have a multiple of data sets, and they can be classified into different parts, so that we have red dots and maybe blue dots. These are the train sets. So by the train sets, your classifier can be well trained, and then in real practice or during testing phase, you might have new data coming in. Then this new data needs to be classified properly, right? This could be maybe in this class or the other class. In order to do that, we can think of various the distance functions to be employed. Distance functions have been developed in many ways for many different applications. One of a very simple distance function is Euclidean distance function. Right? Although we can apply other distance function to make the algorithm simpler. We simply use a simple distance function, okay, which is Euclidean. And also, to measure the distance, there are many different ways of measuring, right? Let's say in the training session, these are the class 1, the other one is class 2. When it comes to new data item, then how can we measure? Can we measure the nearest data item or nearest class? If we think of the nearest class, then then we definitely need to see many ways that we can do, right? If it is a class that contains multiple data items, then what happens is that, do we want to make a measure to the boundary of that class, or do you want to measure the nearest item in that boundary, or do we want to measure anything that can be representative to this class? Could it be the average of those, or could it be any specific object of those? When we measure the distance, we can also think of measure to the nearest boundary or the longest boundaries. They're all possible considerations, right? So there's no true-false type of solution, but you can choose depending upon the application, depending upon the data items. Okay. As I said, I'm going to we learned here the concept, classification concept. The first concept that we learned for classification is Bayesian theory. Therefore, we were able to build a decision tree. And then now we do K nearest neighbor. And the third, the concept for classification that we are going to consider is SVM, support vector machine. Each of these will be experimented in our hands-on exercises using R, okay, R script. So we probably not do R script today. So when I come back from that meeting, we'll do R script. Okay, that way the students who can come in my class in person can get it more clearly. Those who wants to come from online class can also do. So you can also join. Meanwhile, because in my experiments, I'm going to give you all script-based lab, hands-on lab, but today I have Excel-based. This is not really hands-on, but some of you really like this. Okay, this is easier for you to practice. So I'm going to do this today as a little bit of exercises, and then I will do some other R scripts. Well, I'm not going to do R script today, but I'm going to do SVM. Okay, so here's the things. Remember that we have examples. These examples that we covered. So I'm going to use that. So in Excel program. So I'm going to make a new. Alright, so I'm going to bring a new Excel program here, and I'm going to you can also type that, right? Customer, age, income, number of credit card, and then response. Response is like a class, right? This is a class. Oops. Okay, so I'm going to make this a little wider. Okay, customer, we have John, age 35. So what I'm going to do is that I already typed that so that I will copy of those. Okay, so I'm going to do this and the copy. Let's see, copy. Alright, so this is it. So what I'm going to do is that I'm going to what I'm trying to do is that I'm going to insert a chart here. And the way that I can visualize the values here to this chart can be done by first selecting the data. So I'm going to add the points. The x value could be let's say age. So we do this, and x value is this, and then y value can do this. This could be the y value. Okay, so that we have that and okay and okay. All right. So each value here, each dot here represents one of the data items there, right? So each one of those. So for example, this age 20 some and the income 50. So here not right? That one, and the other one probably here then. The age is close to 60 and income is 170, close to 60 and 170, which is a ton, right? So that is that, and I'm going to, for example, X is, let's say primary and that, and X is title, let's do title, option. We don't want to demo option right now. And chart title also, that's fine. Data labels, let's make data labels, and center, that's fine. Right above, I think we need to make it above. Alright, so pretty much that, and let's say what can you do for chart. Can make this for example ages, and this maybe income, and this chart title response. Okay, and again for this I would like to do rather than having the by default this the label is y label, y axis, so 200 for that, but I'm going to change this to select data, then I'm going to do add for that is, wait a minute, not that. Select data. Maybe this. Cancel for that.
Hi, and welcome to the
I think there should be, yeah, format data label. So not Y label, label property. What was it previously? That one. Okay, again. Format data label. Let's say data label. I'm going to put that data label there. Okay, and format data label, value from cell. Here I'm going to do this. Okay. So that right now I have that response label and the income. So I do not want to that income, only label. Perfect. Fine. So we know that, for example, this guy, yes, this guy represents the age mid-30 and the income about 50. Age mid-30 and income about 50. Maybe this guy, David, right? So that is the thing right now. We can do now. Let's try to see. This represents a training data, right? So we have 1, 2, 3, 4, 5, 6 training data. We have 6 the records can be used for training, and those 6 records are visualized on this chart. And then in the testing phase, for example, we have a new guy, Sam. His age is 29, and his income is, let's say, 75, and his credit card is 1. Then what is his response, right? That is our concern. So we may also, if we click this, then design, we can select new data and add. Then this guy is that, this. Yeah, that appears here already, right? This. All right, 75. So we do not know if you see the guys surrounding here, then you need to see what is the k nearest neighbor. Let's say if we would see one nearest neighbor, but I do not know which one's closest, 2 or 3, 4. If we have a 4, then definitely those 4 are closest neighbor. They are away from these guys, right? So how can we calculate this? That is the issue in our Excel program, right? So I can leave it here, right? I'm going to make it shorter there, and then I'm going to put here, for example, distance. What we need to do is that we want to measure the distance between these orange and blue, and another distance between orange and another blue, and another distance between the orange, blue, and another. We need to calculate all of this. If we have, for example, 1 million data points as a training set, then we need to calculate 1 million times, right? And here, say rank. How can we make a rank of those? Okay, and then how can we do response, for example? So what is his response? Okay, that's what we want to find out. Distance, first of all. For this distance, I need to do square roots, right? SQ, need to do square roots. That square roots can take, to put here, another, this guy minus that guy, but I want to make that, I want to lock that data by putting a $sign there, and this is a Euclidean distance, so x1 minus x2 and square roots, and plus I want to make this guy minus that, but I'm going to lock it because we need to reuse that for the rest of the computation. I need to put here number 2, enter. So this is the distance. I'm going to compute that all the way down to 1, 2, 3, 4, 6. 1, 2, 3, 4, 5, 6. Okay. So that I have that. So now I know the distance. Right now we can see the rank very easily from this small data sets. But how about if we have 1 million data? It's very hard. So there is another one here. That click, and the rest of that click, and order either descending or ascending. So if we want to make it ascending, so the closest, the smallest will be the rank, higher rank, right? I mean the rank in the low number. Okay, so if we make that and enter, then we can see quickly the ranks. Okay, so this guy is the shortest distance between this guy and that. What is this one? I have number 3, AG22. So AG22 here. This may be the shortest, and second shortest is this guy, nearly 25 and 40. So 25 and 40, 25 and 40, and this guy is the shortest, right? And somewhere here, and then so here in this response, you can simply say this, right? Then I'm going to do in this way, right? That is the rank right now, right? So no in that. So the closest distance, rank number 1 says yes, number 2 say yes, number 3 say no. If we have, depending upon k nearest, if that is for example 3, then we look at number rank 1 and 2 and 3. So we vote, the majority vote in this case yes, yes and no, then yes, which means his response definitely will be yes, and so on and so forth. If we have number 2, then definitely that is yes, and some others, right? So this is somehow you can get from the Visual Basic. All right. So I'm going to reduce this and come back here. So we'll do this k nearest neighbor algorithm-based classification in our next class as our lab exercise using all script. Okay, this is a simple version of classification using Excel, but we could do a lot more with R. Okay, this is a classification. And now we'll do okay. Support to vector machine. Okay. Basically, what happens here is that we have. Let me ungroup this. What happens here is originally we have let's say n plus and minus somewhere, right? So we have, what is this? This is x. X is not really, oh, this is a something else, right? So we have data points, the labels, right? Positive and negative. What is the machine, vector machine, so that they can classify. If we bring here, then they can this we call this hyperplane. This hyperplane may classify those two groups, plus sign and negative. Minus sign. What about this? We bring that closer to that plus sign. That is also a possible classifier. Another one maybe close to negative. That is also possible, right? So so we need to find out some plane and margin. Say this is optimal plane, so that we have some margin from this dark red to light red or blue, right? So what happens here is that for any data points x, to find out where that x falls in, then we need to make a vector to that, and then we make another vector perpendicular to this hyperplane. So this is always perpendicular to that hyperplanes, right? And then we need to make some dot products between this vector and that vector. Then that is somehow projection to this perpendicular vector to hyperplane, which is a support vector. So depending upon the relationship of those, we can tell that that may be classified to negative or positive. Mathematically, that is defined more formally. As I said, we are not going to do much on this support vector machines, but we're going to use some of the tools developed in R script. So in this class, I want you to understand the basic concept of support vector machines. So support vector machines, not necessarily in this direction, but could be that direction. If we have a multiple, so many target values, either positive and negative, right? So we want to try to draw one or more lines. Therefore, it could be hyperplane that can divide positives from negatives. Which hyperplane can maximize the distance between the nearest data points or the classes, okay, to make it maximize. The examples could be found in many applications. Remember that our KNN application, so people's who may respond to whatever the request, depending on the customer's age and income. How can we classify their response quality? We can classify them very quickly if we have some data available, right? Same thing here. For example, tennis plays. So that depends on the temperature and the humidity. So for some reason, if a high humidity and high temperature, then there's a negative. So do not play tennis. So lower temperature, if we have very low temperature, then doesn't matter. Very low humidity, then tennis can be played with no respect to the temperature, right? That's what it is. So how can we decide, for example, okay, tomorrow's temperature is such and humidity is that. It could be somewhere here or somewhere there. Then how can we determine that? Okay, somewhere here, let's say here. Then it's very hard to see, right? It could be, we could play or we could not. So what is our determination based upon the training sets that we trust? So training sets needs to be the sets that we trust, okay? So all the data here, X1 and X2, are the training data sets, and there is a Y1. Y means that is our targets, that is our decision, okay, that we want to make. So it could be yes or no. So there are multiple different SVMs available. It could be the linear SVM, or maybe some other shape. If it is non-linear SVM, oh, that is tough, right? If it is a linear, then it's relatively easy, so that we can make the form like a linear function, right? So according to that linear function, like this linear function, we can expand this hyperplane. Okay, we can expand that. So once we have that, then if this satisfies, then we can say, oh, that is in positive. If this is satisfied, if this is greater than that, then that is a positive. Less than that, then that is negative. Okay, so this is a hyperplane, okay, which is represented by that. So given any data, and we apply that here, if that satisfies, then positive. If the other satisfies, then that is negative. They are exclusive. Okay, that is the definition of hypertext. So this is maximizing margin between this and that. Once you have hyperplane well defined, then classification is very, very automatic, right? That's what we would like to do. So there are a lot of applications available. So right now what we will do is the classification lab experiments can be designed in this way. This is not only SVM, but KNN, and also decision trees. So when it comes to that, then we usually have a set of data. You can say that, oh, this is data. We have one table, okay? We want to make it some model. That's what we want to do, because we have attacks, anything that could be an attack data. The given the data that can include attack and all other non-malicious data also. So what we need to do is that we want to split them. Okay, half of them, let's say, that is a training sets. Half of them that is a training sets. Half of them, maybe, or even smaller, could be a test sets. I wanted to recall our Excel example that we did earlier today. We have some table, right? And we have one extra records that is for testing data sets, all others training data sets. In the training data sets, it has a positive and negatives, right? It has attack data and non-attack data together. In cybersecurity, if we have data sets, we collected, for example, the firewall, the logging data. If you look at the firewall logging data, that contains the packets, attack packets and non-attack packets. Okay, so we can divide those two things. We label each records. Say this is attack packet, this is a non-attack packet, or other packets. So some of them used as a training set, some of them are testing sets. So as we do train, if your classifier trained very well, then by applying the tested data sets, you can conform. Okay, If it is not, then your training sets may not be good, right? So once you have that, then test data set comes in your model and then can be classified in this way very nicely, right? Of course, there could be, although there's no a perfect classifier, right? The real world doesn't follow your classifier. So we need to model the classifier. So that is our design. So our design does not reflect the real world. Real world goes by itself. So our modeling techniques follows the real world evolutions. When you apply our classifier as a model to determine the data, test data sets, then there could be some false positive, right? And there could be some false negative. Here, this is a test negative, all positive, but in positive sets, there could be false positive. In negative sets, there could be false negative, right? We need to reduce those things. That is our goal. But at least we need to know if there is a false positive and false negative. We need to detect, we need to identify those falsifier. Okay? There are a lot of research issues, but in the lab experiments next week, we'll do simply using the tool. So all rely on tools, which means the software developed by someone, right? It could be real, much better if you can develop. That is the reason I always asking our students to, first thing that they need to do is they need to understand the concept. Next step is to use tools. So they need to learn development techniques. And then third step is that once you know the concept, once you know the tools, which is somebody's development, then you can improve based upon what you understand. So that will be your implementation. Yours will be the good classifier to the example that you want to classify, right? Usually the tools that you are using may not be really optimistic to the application that you are working on. No one wants to develop any classifier to your specific application domain. You are the person to do that. So you need to know some of the development skill. All right, so I'm going to see you in the next class. Have a good day.